Welcome back to online geometry lessons. Today we're going to be working with secant segments, learning about them and how they are formed in, out, and on a circle, and how they impact the angle measures of their segments. First off, I want you guys to draw two lines that intersect the circle at two spots each. So here's one line, here's the next line. They each intersect at those two spots. These lines are called secants. So the definition of a secant is a line that intersects the circle two times. Now, where are these going to intersect? Well, these lines eventually, if you connected and kept going with them, would intersect out at a point. What we're going to care about today are the angles that are formed from these lines where they intersect. Today we'll have three different cases where they intersect outside the circle, inside the circle, and on the circle. So the first one, intersection inside. Let's draw the picture and then we'll see the relationship. Two secants intersect inside the circle. Okay? Intersect inside. What's formed? The measure of an angle formed, let's say this angle right here, is 1/2 the sum of the measures of the arcs intercepted by the angle. So here is one arc that is intercepted by that angle, and its vertical angle. Well, its vertical angle is here, so this arc is this one. So if we call this point A, B, C, and D, we can say the measure of angle 1 is equal to 1/2 the sum of arc AB plus CD arc. So if they intersect inside, 1/2 the sum of the two. Let's do an example. We're looking for the measures of angles 3 and 4. Now right off the bat we have to identify which one we're going to solve for first. Well, if you notice 3, this angle right here, intercepted arc EH and its vertical angle 88. So we know the measure of angle 3 is equal to 1/2 of 76 plus 88. This becomes 164, 1/2, which is going to be 82. Measure of angle 3 equals 82 degrees. Now, if this is 82, how do we find 4? Well, it's a linear pair. Makes 180 degrees. 180, subtract 82, measure of angle 4 equals 98 degrees. So if they intersect inside, half the sum. Okay, what about if they intersect on the circle? If a tangent line, let's draw a tangent line, and a secant line that goes through the point of tangency, there's that point of tangency, are drawn on a circle, then the measure of each angle formed, here's angle 1, is going to be 1/2 the measure of the intercepted arc. Well, here's the measure of the intercepted arc. Notice there's only one intercepted arc in this case. So if I call this AB, we say the measure of angle 1 is equal to 1/2 AB. Now I want to make a connection to what we did back in 10.4, which was inscribed angles. Inscribed angle looks like this. What type of line is this? Isn't that a secant line? You bet it is. What's the relationship? This angle equals 1/2 of the arc. Same exact concept here. If these lines intersect on the circle, they will always give a 1/2 of the arc measure. Let's do an example. Let's look for this angle RPS. Let's just call it angle 1 right now. That's what we're looking for. In order to figure out this angle measure, we need to know how long that arc is. What's the degree measure, I should say. Not how long, but what's the degree measure? How are we going to do that? Well, we have 360 in a circle. 114 plus 136, what is that? 250, which leaves 110 degrees here. If this arc is 110, cut that in half. Angle 1 is 55 degrees. We could also find this angle, call it 2, by subtracting measure angle 2, 125 degrees. The idea, if it's on the circle, it's half of the intercepted arc. Last one. What if they intersect outside? Well, let's draw 3 situations so you can at least visualize what's happening. 2 tangent lines. Okay. 2 secant lines. 1 tangent line. And secant line. The angles we care about, we'll call them angle 1. Okay. All right. I just took a break here, so if I missed my step here, I apologize. So I've got these drawn. We're looking for the angles. These are the different types of segments. The relationship compared to what we've learned before is we're talking about the arcs that are being intercepted. I'll try to make sure they're the same color here. The measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. There's going to be 2 intercepted arcs in each case. The way I like to think about this theorem is the measure of the angle is equal to 1/2 of the difference between 2 arcs. And I like to use the letters B and S. Why? Because one of them is going to be bigger than the other. The one that's bigger is always the one that's opposite that angle. So we always take the biggest angle and we subtract, or biggest arc, and we subtract the smallest arc. Okay? So instead of doing the positive difference, let's just get into a habit of doing the big minus the little. It's half the difference. Let's do an example. So here's the angle. It doesn't matter what type of segment it is, it's always going to be half the difference. So here's the big one, here's the little one. The measure of angle x equals 1/2 the difference of 162 and 42. This becomes 120. This is 1/2. So x equals 60. Just that simple. Find the 2 arcs, subtract them, take it times 1/2. All right, now this one, notice the formula is going to be a little bit different. The angle measure is 62, so 62 goes in this position. Equals 1/2 the big, which is the one furthest away, 141, subtract x. All right, now let's get back into our algebra mode. Simple way of solving this. Well, we've got a half here. Can't we move this to the other side by multiplying by 2? We certainly can. So that would be 124 equals 141x. Got rid of that fraction. Now, let's move this x over here by adding it, and let's move the 124 over here by subtracting it. X, now it's positive, so we'll subtract 124, we get x equals 17. Now, let's try to simplify this just a little bit before we finish this last question. As we're doing our 3 different intersections, so they intersect in, on, or outside. Really, here's what's happening. If they intersect inside, the angle is equal to 1/2 the sum. If they intersect outside, so inside, if they intersect outside, the angle equals 1/2 the difference. If they intersect on, the angle equals 1/2 the arc. What do you see in common? Well, there's always a 1/2. No matter what, there's always going to be a 1/2 in front. So what do you have to memorize? If it's inside, it's a sum. If it's outside, it's the difference. If it's on, it's just one arc. As simple as I can make all of this for you boils down to you memorizing the fact that we're taking half the sum, half the difference, and half of 1 based on the drawing. Now let's take a look at one last example that you guys will come across, which will use some algebra skill. A jeweler wants to craft a pendant with the shape shown. Use the figure to determine the measure of the arc at the bottom of the pendant. We're looking for this. Let's call it x. This is 40. Problem, we don't know any of the other measurements. We don't have enough unless we can think back to algebra. Remember, this whole circle is 360. So how can I represent this part of the arc? The whole thing is 360. This part is x, so can't we say 360 minus x represents this portion? Certainly can. So we can say the angle equals 1/2 big minus small, because it's outside. So the angle is 40, 1/2, 360, oh, sorry, the big one is not 360 minus x, the big one is x minus 360 minus x. Now be careful, this negative sign needs to be distributed to both. Negative 360 plus x times 1/2 equals 40. Doing little algebra tricks. X's turn to 2x minus 360 times 1/2. Now we could move that 1/2 over by doubling, or we could distribute. Let's distribute this time. 180 equals 40. Solve for x. X equals 220 degrees. So find the measure, 220 degree pendant, the arc at the bottom. Okay. Hopefully this helps. And, you know, really, the summary, as much as I can make it, you've got to know this. If you start getting bogged down into all of the different theorems, it's going to become much more daunting. But the mathematics isn't too bad. It's just multiplying by 2 or dividing by 2.